So recall that the weak topology on X induced by a family of functions f is the weakest or smallest topology that makes each function continuous. Moreover, the convergence of nets in this topology is completely characterized by pointwise convergence. Keeping this in mind, we're going to take X to be the bounded operators on a Hilbert space and Y to be the complex numbers. Now, we define the weak operator topology on the bounded operators of Hilbert space by taking F to be the family of these functions indexed by f and g in H. And what this function does is it sends t to the inner product of tf g. Now the strong operator topology, we're going to define it by taking f to be the family of functions indexed by f in the Hilbert space. And what this function does, it sends t to tf. Now, since the convergence of nets in a weak topology is completely characterized by pointwise convergence, we see that a net of operator converges weakly if and only if these inner products converge for every f and g in the Hilbert space. Moreover, a net of operators converges strongly if and only if they converge pointwise for every f, right? This is just pointwise convergence. Now, we'll see that the weak operator topology is weaker than the strong operator topology, which itself is weaker than the norm or the uniform operator topology on the bounded operators on a Hilbert space. Now, if we assume that Tn converges to T, then the limit of that sequence or net is 0. Now, when we look at an f in the Hilbert space, we see that the difference of Tnf and Tf is bounded by the norm of the difference times the norm of f, which is a fixed number, so that tends to 0. So we see that that uniform convergence or norm convergence implies strong convergence. Furthermore, for f and g in the Hilbert space, we see that the inner product of Tnf with g converges to the inner product of Tf with g simply because the inner product is continuous. In general, these topologies aren't equivalent, so you might have sequences or nets of operators that converge weakly but don't converge strongly or uniformly. Now, interpreting the statement in terms of closures, we see that given a subset B of bounded operators on a Hilbert space, we find that the closure with respect to the weak operator topology might be larger than that of the strong operator topology, and that itself could be larger than the closure with respect to the uniform topology generated by the subnorm. In particular, when B is a C-star algebra, well, C-star algebras are closed in the uniform topology, and hence its closure in the weak operator topology might be larger than itself. So in the next video, we're going to see that the operations on L of H, like the sum, composition, and involution, are all continuous with respect to the weak operator topology.